Hello, Algebra 1 students. Welcome back. This is video number 3. So on the Interpreting Graphs assignment, we are going to cover problem number 3 in this particular video. So let's get started because we've got a lot of time into this at this point. Okay, so this is going to be a problem just like 3A. The example is a company offers these particular prices for video games. So for one video game, it's going to be $55. For 2 video games, it's going to be $100. And for 3 video games, it's going to be $145. So what we need to do at this point is set up our axes, okay? So what I would recommend, let me get a line going here. All right, so I would say that on our axes, we want to, I'm going to make that my y-axis. Going to darken that, and I'm going to make it a little bit thicker so we can see for sure what it is. And then I'm going to paste it. Obviously, you guys can just draw this on your paper. You don't have to go through all this technological part, but I'm not going to be able to draw a straight line to do this, so bear with me here for just a second. Okay, there we go. So this is going to be, go back over to my pen, this is going to be my x-axis. This is going to be my y-axis. This is actually going to be the number of video games across here. So I don't have a whole lot of room down there, so let's see, number of video games. All right, and we can say that this is going to be 1 video game, 2 video games, 3 video games, and so on and so forth. Okay. I think because of the amount of money that we're dealing with here, what a lot of people do is when they're setting up their scale for their y-axis, they'll just go straight to whatever this number is and start counting by that. To me, when we look at these numbers, it makes more sense to me to use nice even values of 50. So that way I can let each one of these count as 10. So I've got 10, 20, 30, 40, 50. But then each one of these, that scale needs to stay the same. So then this would be 60, 70, 80, 90, 100. And of course this one up here is going to be 150. Okay. Oh, I lied, sorry. This is going to be 150. All right. Now, next thing we need to do is plot our points. So for 1 video game, it was going to be $55. So right about here. For 2 video games, it is going to be $100 on the nose, so right here. And for 3 video games, it's going to be $145. So this is 140, this is 150, 145 is going to be right in between those two, okay? Now what I can do is insert another line. And this time I'm going to start it from this top point, and I am going to drag it down. And if we have done this properly, we want to bring it all the way over to the y-axis, and then I can extend this part if I would like. Give me a second here. Try to get it to stop wiggling. Yeah. Okay, that's pretty close. All right. So that's all I have to do to graph this thing. So, and I think that was all they needed for this particular question. Okay, so here's what I'm going to do. I'm going to ask you guys to make a graph for this set of data. So go ahead and pause the video and make that graph now, please. Okay, so hopefully you had a chance to get that done. And what I'm going to do is toggle back and forth real quick. I am going to copy that line and paste it, and then I'm going to go copy the other one too. Pardon me, bear with me guys. And of course it's going to make me do this again. That's okay. All right, now so across my x-axis is going to be the number of t-shirts. So this is, remember, my x-axis. This is the number of t-shirts. This is going to be money or total cost. I'm going to say this is going to represent 1 t-shirt, 2 t-shirts, 3 t-shirts, 4, and 5, even though I can't get that far. Now, money-wise, so let's decide how we want to set this up with our y-axis. We know that for 1 shirt, we're going to pay $20. For 2 shirts, we're going to pay $35, and for 3 shirts, we're going to pay $50. So we need to decide. I'm almost thinking, I like to keep these pretty simple. I almost feel like we could do something like this. Some people might say go by 2s, but then that would be 2, 4, 6, 8, 10, which would mean this could only be 20. This would only be 30, right? So I'm not going to be able to get up to my $50 mark. We could try going by 3s, but that's just not a really it's not a real user-friendly number all the time. So what I'm thinking maybe we could do is go by 5. So if this is 5, 10, 15, 20, this would be 25. So that would be $25, which would make this $50, and this would be $75. So the beauty of this is I can fit all of my data on it. These are nice, easy, workable numbers, and this is also going to give me a little bit of extra space on my y-axis to extend my graph a little bit if I decide I want to. So for 1 shirt, it's going to be $20, 5, 10, 15, 20. For 2 shirts, it's going to be 35. So here's 25, 30, 35. For 3 shirts, we are up here at 50, and we've got a spot for that, so we're good to go. Make sure that doesn't go away. All right, now I need to insert a line. I'm going to start up here again, just like I did last time. Try to get right on the nose there. Whoops, that's not what I wanted to do. Bear with me, I'll get there. Okay, so remember, we want to extend this line through the points and go straight into our y-axis so that we have that y-intercept, because that gives us important information. And I'm actually extending that line out quite a bit. Okay, so there you go. Hopefully you have a line that looks somewhat like that. If your y-axis is off a little bit, that's okay. Just make sure that your scale is consistent, just like I went by 5s all the way up. Different things like that. So if yours looks weird and you want me to take a look at it, you can send it to me and let me know. Okay, let's move on. So 3B, they want to know what is the slope of the line containing the data points. And I am hoping, you know what, I've got this set here. I think I intended for that to be put in the right spot. And it might be, but I think I'm just going to go back to the earlier graph. So what is the slope of the line containing the data points? So we've got to find the slope of this line. Remember, slope is rise over run, right? So if I wanted to look between this point and this point, I would have to count out my rise. So how much has it gone up? I can do that in a couple of ways. I can either do that from the graph, or I can do it from the values within the table, because you can see that my initial one, this dot's like right in the middle. So I can look up here at my table and see easily enough that that's a y value of 55, right? So this is 1 comma 55. This is 2 comma 100. All right, so my 155, that means what is going to be my difference between 55, and 100 minus the wiggle. Okay, so how much have we gone up here? And the amount that we're going to go up in this particular case, you just do 100 minus 55, that's going to give you 45. So my rise is actually 45. And I'm going to show you guys something else actually while I'm at it. Okay, remember our slope is also y2 minus y1 over x2 minus x1. Basically what I did to find my rise is I took my y2 value of 100, and I subtracted off my y1 value of 55. And that is how I got that 45. Okay, now x2 minus x1, my x2 is this one here, that's the 2, and my x1 is 1, so this is 2 minus 1, and of course you can see that according to my scale, the difference between this point and this point horizontally is just 1. So this is 45 over 1. So my slope is 45 on this one. Okay? So now what we would do is jump down to part B. We want you guys to try and figure out what is the slope of the line containing the data points. So I'm going to go back up to this because this is the one that you guys did, and I'm going to see if you can pause your video and find the slope of this line for me. Okay, now hopefully you had an opportunity to get that done. This one is going to be a little bit easier to just count our rise. Remember, we were counting by 5s, right? So this, I'm going to go from this point to this point. You don't have to. You could go from this point to this point, or this point to this point, whatever you want to do. You could even start over here at the y-intercept if you wanted to. But this just happens to be what I chose. So my rise, remember, I'm going up by 5s. This was 5, 10, 15, 20, 25. So this is going to be 5, 10, 15 over this whole horizontal piece here represents 1. So my slope is rise over run, which in this case is 15 over 1. All right, so your slope is 15. You also could have gotten the ordered pairs and said this is for 3 t-shirts, that's going to be $50, and for 2 t-shirts it's going to be $35, and you could have subtracted those values, so taken 50 minus 35, which you would in fact get 15, and then 3 minus 2, which you would in fact get 1. All right. Okay, so that one's done. Let's move on to the next one. Don't need 3b, we just did that. What does the slope represent in this problem? Okay, so what does the slope represent? Here's the thing. Labels are golden here, right? My slope is rise over run. Okay, so this one's a really big one for me. The rise is going to be based off of my y-axis. Well, what is the label on my y-axis? Ding, ding, ding. It is dollars, okay? So this is $45 is what that represents per, this represents the word per one what? What does my x-axis represent? Well, that's video games, okay? So what this represents is $45 per video game. Okay, so literally when they ask you what does the slope represent, they are asking for labels. I can get those labels off of the, I can get it from the table. I can get it from the graph if it's a graph that is labeled properly. So there's lots of places that you can get that. So now what I need you guys to do is come up with, for the you try problem, I want you to come up with what does this slope represent. Do that now, please. Okay, and hopefully you got on that right away, because remember, my 15 is my rise. That goes with my y-axis. Well, my y-axis is labeled in dollars per. What does the 1 represent on the x-axis? 1 what? Well, it looks like 1 t-shirt. So my slope represents $15 per t-shirt. Okay? Just labels. That's all that you have to do. All right, let's go down here. I think we were on 3D right now. This one, I actually don't like how this question is set up because it doesn't make a heck of a lot of sense. We're going to go through it because it's on your assignment, and I don't think I have the freedom and flexibility to get rid of it. But in this case, I just don't think that that y-intercept makes a lot of sense, because let's look at what that means. The question is asking, what does the y-intercept of the line what is the y-intercept of the line that contains the data points? Okay, so we can get the y-intercept. This is not talking about the interpretation yet. What is the y-intercept from my graph? I'm going to go ahead and light that up with an, oh, do I have an extra line on here? I think I do. Let's get rid of that. We don't need that. There we go. That's a lot better. Okay, so what I'm going to do is make my y-intercept with a red dot. That's what I was trying to do when I got distracted about that extra line. Okay, so there's my red dot. The y-intercept, remember, what is the scale on my y-axis? it's 50, right? Or each one of these things is a 10, so that I can get up to 50 by the time I get to this first line. Okay, so that means my y-intercept for this first one, is this it? These are the questions I don't like. Okay, so my y-intercept, what is the y-intercept? My y-intercept was 10. So I'm going to say that my b equals 10, all right? So now I'd like for you guys to try it with this other line. Again, what is the y-intercept of the line that contains the data points? But we need to go back to our graph that has data on it. So there you go. I want you to get the y-intercept and do that now for me, please. All right, hopefully you had a chance to recognize that the y-intercept is going to go right there. Okay, that y-intercept, remember we were counting by 5s. So in this case, your y-intercept was 5. I'm going to go ahead and put that back on the original slide. If I can find it. There we go. Next one. So my b was equal to 5 here. All right. And next slide. Now this is going to be part E from number 3. What does the y-intercept represent in the context of this problem? This is the one I was talking to you about that I really don't like this question a whole lot because it's weird. Okay, so I want to talk you guys through it. It doesn't make any sense in this particular case. Here's what the y-intercept represents. Okay, same idea as using these labels, right? It basically represents, here's my y-intercept, and that y-intercept represents $10, right? $10 for what? How many video games am I buying at this point? 0 video games. Okay, so this basically is trying to say it's $10 for 0 video games. That's the best thing I can come up with in a real world context, okay? Here's what this means. It means that when you buy the first video game, it's actually $10 more than all the rest of the video games. So this first one was 55, and then the next one was only 45 bucks. And then the next one was also 45 bucks. And then the next one will be 45 bucks. But this first one they're charging me an extra $10 for. And that's what that y-intercept in this case is representing. Like I said, I don't like this question with this particular situation, and it's the same way on your assignment. So just go ahead and answer the question, but know that that's not something that, it's just weird. If it doesn't make sense to you, there's a reason for that, okay? Now for the U-try problem, they want you to do the same thing. So what does the y-intercept represent? I'm going to go back here and let you guys work on that one now. Okay, hopefully you had a chance to do that. And again, this doesn't make a whole lot of sense logistically, but what this y-intercept is representing is, that's 5, remember? So it's going to be $5 for 0 shirts or t-shirts. All right, doesn't make a bit of sense. But remember, realistically, what it's actually meaning is that I'm paying an extra $5 for the first shirt. Okay, that's the best way to say it. So, so $20 for the first shirt, which is $5 more, and then I start paying $15 per shirt after that. That's why we're putting an extra 15 on there for every extra shirt that we get. That's our slope of 15. If your friend says that he can get 10 video games from his website, from this website for $430, is the friend correct? Well, here's what we need to do. We need to make an equation. So if you'll remember, we've got y is equal to, and you can go back in the video, or if you have this on your notes page, you'll be able to see, I can look up here and tell how much it's going up. Okay? So the y-intercept, if I remember correctly, that was meant to be a 10, because we said that y-intercept was 10. So I'm going to have a plus 10 in that spot, and then I'm going to end up paying $45 per video game. So it's going to be 45x. All right, so when we get this equation, that's what's going to allow us to check this really easily, okay? So your friend says that he can get 10 video games, so that means 10 goes in place of x, and he says he can get that for $430. So let's just double check this. Well, 45 times 10 is 450. plus another 10 is $460. So we're going to say, no, friend, I'm sorry, but you are incorrect. You cannot get 10 video games for 430 bucks. That's not enough money, okay? Now, I need you guys to try the you try problem. And I'm not going to take the time to fill out this whole thing. You can go back in the video if you need to, or if you have notes on it, that's great. But remember, in this case, that y-intercept was $5, right? And this was one t-shirt. This is t-shirts, right? 2, 3, and so on and so forth. Okay? So your friend says that she can get 15 t-shirts from this site for $230. Is she correct? I would like for you to come up with an answer for that, and then we will check your answer when you push play. Okay, so this one's got a lot of stuff buried in it. Okay, so we have to come up with the equation. Y is equal to, we're going to take our slope. The slope of the line, it looks like, was 15 per shirt, right? Plus, what was my starting point? My y-intercept was 5. All right? So really all that's telling me is my first shirt was an extra $5. That's about it. Okay, so we need to check out 15 t-shirts. So since it's 15 t-shirts, we've got to put 15 in place of the x, and we're checking to see what y is going to work out to be. 15 times 15, you can, hopefully you've already plugged that in, you get $225 for that. Plus another 5 is $230. So yes, friend is correct in this case, okay? And that can be your justification. You could say yes, because 15 shirts is gonna cost $230. So if you need to put something extra on there, you can write something like that. Okay, and I was wrong. I said that we were almost done, and we still have one more question. So in this particular part of it, we are using the same situation. How much would it cost this time to buy 30 video games? Okay, so rather than toggling back and forth with all those slides, I am just going to rewrite the equation. We said that y was equal to 45x plus 10, I believe. So for 30 video games, we have to plug in a 30. So 45 times 30 plus 10. All right, so when we take 45 times 30, we get 1,350 plus an extra 10. So that's $1,360, okay? Would be the cost for 30 video games. All righty? Now, next problem, I'm going to go ahead and help you guys out, and I'm going to write down what that equation was. We had y was equal to, we have a y-intercept of $5, and then these things were $15 per t-shirt. So please pause the video now, work this problem out, and then we'll check your answer when you get back. Okay, so this should be y is equal to 15 times 40 plus 5. I know 15 times 4 is 60, and then with an extra 0, I'm looking at 600. Plus 5 is $605 for 40 t-shirts at that cost. Okay? All right. And that's going to be it for number 3, which is really good because we are in a 25-minute video almost. So thank you guys for your diligence and your patience. And if you have any questions, please make sure you let me know.